For part 2 of video 5.5, we just have to finish up the last 3 examples. We'll start with where we left off, finding sine of theta and tangent of theta when the cosine of theta is 5/13 and the terminal side of theta is in the first quadrant. So let's remind ourselves that cosine of theta is, we know it's 5/13, but it is adjacent over hypotenuse. And so because we're going to have our angle somewhere here, the adjacent side is going to run along the x-axis. So I know that my adjacent side is 5. And now I don't know what the opposite side is. I know that theta is going to be here somewhere, but I don't know how far up this side is going to go. But I do know that the hypotenuse, this length, has to be exactly 13. So let's use that formula that says that the radius equals the square root of x squared plus y squared. And the radius is going to be 13. I know my x value is 5, and I'm just looking for what is the y value. Okay, so to solve, we need to square both sides, and I don't know why there's a plus sign there. That should be equal, so 13 is equal to the square root of 5 squared plus y squared. 13 squared is 169. We got rid of the square root symbol. When we squared, that canceled it out. So now we've got 169 equals 25 plus y squared. Subtract 25 from both sides. And we end up with 144 equals y squared. To solve for y, we just have to do the square root to cancel out the squared. And we get that y is going to be 12. Now, when you're solving, technically this should be either positive or negative 12. I know it's going to be positive 12 because the original problem told us that it was in the first quadrant. And so yes, theta could have been down here, and we could have had an x value of 5, and this distance still could have been a positive 13, and my y value would have been negative, but because it tells us it's in the first quadrant, I know it's a positive value, and so it's going to be up at 12. I believe that's there. Yep. So that is my y value. That is the opposite. So we can draw, oops. You can draw your hypotenuse like that. And theta is always going to be formed by the terminal side and the x-axis. It's not going to be theta up here. Okay. So now it says we need to find our missing 2 pieces. I knew my hypotenuse was 13 units. I now know that this side is 12. So when we are asked to find the sine of theta, sine of theta, I shouldn't just write sine, sine of our sine of theta is the opposite side, which we solved for 12 over the hypotenuse 13. And the last question, tangent, is the adjacent side, which we already knew. Nope, sorry. Tangent is opposite. It's at 12 over the adjacent side 5, and that's where the 5 that we already knew was. On the next page, we know that the terminal side of an angle theta in standard position contains the point with coordinates 8, 15. So I know it's going to be right 8 and down 15. 2, 4, 6. So the terminal side is going to go through that point. And now I have to decide where do I put theta. So I end up actually with 2 right triangles. I've got this right triangle up here, but I also have this right triangle down below. But I know that I want to put theta with the x-axis and my terminal side. So theta is right there. I'm going to use this right triangle, not the one with the y-axis, and I'm going to label the values that I know. So I know that that is a positive 8, and I know that that is a negative 15. I will label this as my adjacent side, and I will label this as my opposite side, and this is my hypotenuse. Now I need to find the 6 trig functions. So first we have to find out what is the length of the radius, or what is the length of the hypotenuse. It is going to be the square root of 8 squared plus negative 15 squared. So we're just doing the solving. Get the square root of 289, which happens to be exactly 17. So that is the radius, or the hypotenuse, which is 17 units, which makes finding those 6 trig functions simple. Sine of my angle is opposite over hypotenuse, so we've got negative 15 over 8. I'm sorry, negative 15 over 17. I was thinking ahead. Cosine of theta is the adjacent side, so that is 8 over 17. And then tangent of theta is opposite, so that's negative 15 over adjacent 8. Okay. It is important that we put in those negative values, and actually right now if you would flip back your notes to the back of the cover page, we've got the unit circle. Notice some writing in the corners of each one of those quadrants. It tells you things that are positive and things that are negative. So in this 4th quadrant, I believe it says the positive values are cosine and secant, and that the negative values are sine, tangent, cosecant, and cotangent. And that's because the y values are all negative. So any of these functions that have to do with y are going to have a negative value. So sine, because we're going down 15, there has to be a negative number there. Cosine is positive because cosine is the x value, which was a positive 8, and then tangent is y over x, and so again, because that y value of negative 15 is there, tangent becomes negative, which means their reciprocals are going to have the same signs. So the reciprocal of sine is cosecant. That's going to be negative 17 over 15. Secant of theta is going to be positive 17 over 8. And cotangent, again, is going to be negative. And so we can put that negative out there. And the last example tells us that the cosecant of theta is negative 2, and that theta lies in quadrant 3. So I know my terminal side is going to be somewhere down here, but I'm not exactly sure where to put it. I don't know if it's going to be closer to there or closer to there. So I'll just kind of estimate somewhere in the middle, and if I need to change it later, I can. But the information says that cosecant of theta equals negative 2, and I can write that as negative 2 over 1 to help me identify how long each one of the sides is. So cosecant is hypotenuse over the opposite, because it's the reciprocal of sine. So that means that my theta is going to be formed by this x-axis and right here. And so any point on my graph, theta is going to be right there. This is going to be my opposite side, which means the opposite side should be half as long as the hypotenuse. So I'm going to change my drawing a little bit. And if you want to, you may also. So I'm going to move it a little bit like that. So now again, I've got my theta formed by the x-axis and my terminal side. And when I draw my line perpendicular to the x-axis, this is the opposite side, this is my hypotenuse, and this is my adjacent side. It's seems realistic that this would be negative 1 and that this would be 2. And I had to put the negative 1 on the opposite side because the hypotenuse is always going to be a positive number. No matter which quadrant it's in, you can always label it as positive. The adjacent side, because it's on the negative x-axis, I know it's going to be negative something. The question is, what is that negative value going to be? So we can set up our equation that says the radius equals the square root of x squared plus y squared. And we can plug in the radius of 2. Don't know what my x value is, but I do know that the y value is a negative 1. And so I'm going to get rid of that square root by squaring both sides. So we end up with 4 equals the square root of x squared plus, remember negative 1 squared is going to be 1. I'm sorry. We get rid of the square root. So it's just x squared plus 1. Subtract 1 from both sides. So we get x squared is 3. And to solve, take the square root, and when you're solving, remember that's always positive or negative. I know that it had to be a negative value, so the adjacent side is going to be negative square root of 3. So now we have to use that work to find the remaining trig function. So we already know cosecant. So if I'm going to set up my work down here and say we need to find sine of theta, cosine of theta, and tangent of theta. Okay, we also need to find cosecant of theta. That one was given to us as negative 2 over 1. We need secant of theta, and we need cotangent of theta. Well, because cosecant of theta, right here, this negative 2 over 1, is the reciprocal of sine, I know that that's going to be just negative 1 over 2. Right? Sine is opposite over hypotenuse, so it's negative 1 over 2. Cosine of theta will be the adjacent side over the hypotenuse. That's negative square root of 3 over 2. And tangent of theta is opposite over adjacent. Okay. When I look at that tangent of theta is negative 1 divided by negative square root of 3, I notice two things. I notice one, that I've got a negative number divided by a negative number, and so those negatives are going to kind of cancel each other out. And so it's going to be the same thing as 1 over the square root of 3. Another thing that I notice is that I have a square root in the denominator. And that's generally something that we don't want to do, so we want to get rid of the square root in the denominator. We don't want to change the value, we just want to change the way that it looks. So I'm going to multiply it by 1. But instead of writing 1, I'm going to write square root of 3 over 3. And therefore, I get the square root of 3 in the numerator all divided by 3. So that is the tangent of theta. We had to rationalize the denominator, or get the radical out of the denominator. Cotangent of theta, while we're talking about tangents, because the tangent of theta was 1 over the square root of 3, we can write the cotangent of theta as the square root of 3 over 1, and if you don't want to write the over 1, you can just leave it as the square root of 3. Cosine of theta is going to be the reciprocal, secant of theta is going to be the reciprocal of cosine, so we will write that as 2 over the square root of 3, and again I see that same problem of we have the square root of 3 in the denominator, so I want to multiply it by the square root of 3 over 3, so that we no longer have the square root of 3, we just have 3. And then in the numerator we've got 2 square roots of 3, but we have to remember that that number is negative. So negative 2 square roots of 3 all over 3 is the secant of theta.